start solving equations, logarithms and exponential. I'm going to spend 3 days on this. There's a reason I'm saying 3 days. They can be really, really hard. Can you read that one? Sometimes you can. Okay. Now, couple things that you want to kind of focus on when you're solving these. Is you need to make sure the bases are the same. If the bases are not the same, either an exponential or logarithmic form, you cannot solve it. That's the first thing you want to do. If you have more than one term on either side, you need to condense so that you can get it all into one term, and then you're going to solve from there. So, look here. Are my bases the same? This is a 3 and that's a 3, yes? My bases are the same. What I can do is I can just set x equal to y. You can set x equal to y and just solve for whatever you are trying to solve for. So what we will do here is we'll just say x equals y and then we solve. So number 1, are the bases the same? Yeah, so I just set x and y equal to each other. So x is 2x minus 9, and y is 7. You guys see what I did? Set the x and y equal to each other. Solving for x. So what am I going to do first? Add 9, so you have 2x equals 16. Then divide by 2, so x equals 8. You need to make sure that you don't have any extraneous solution. You have to make sure that if you plug it back in, it works. Now, since this is just a regular number of 7, you're not going to have an extraneous solution, so you can move on. Look at 2. You have the same base. Does it matter that it's an E? Not at all. It's the same base. It doesn't matter. Set it just like we had before. You're going to have 4W minus 1 equals 5 minus 2W. What are we going to move? What? Add. So I'm going to add the 2W. I'm going to add the 1. So I have 6W equals 6. So W equals 1. Yes? You need to check this one now. So you need to get in your calculator and you need to make sure that that actually works. So what I would do is I would do this. I would plug in 1 for W, so I need 4.25 minus 1, so that's 3, yes? Then I do second natural log to the third power. Kind of recognize that number is 20.08, yes? You guys follow me there? Do the same thing on the other side. So you do 5 minus 2, parentheses 1, which is also 3. The third works out. That makes sense? Are they always going to work? No. Will they work a lot of the time? Yes. What's different on 3 and 4? I added some stuff, yes? They all have the same base though. They're all 5. Now, here's what this is. This is 5 to something times 5 to the something power, yes? What does your exponent will tell you to do? If you are multiplying the same base, what do you do with your exponents? You add them together. So this is going to be 5 to the, well, c plus 3c is 4c. Yes? Negative 1 plus 2 is 1. This is still going to equal 5 to the 7c plus 16. Now can you solve it? Same base, yes? What do I do with the exponent? Well, 7 equals 2 times solve, right? I already added them, right? Solve it. And then do the next one, please. So, are we good on 3? You good on 3? You understand what I did on 4? You understand? But, if you keep those answers, they might not both be right. You have to check them. You have to plug them both in. So, plug them in right here, and that's completely fine. So you would do 5 squared, plus 3 times 5 minus 9. So that would be 8 to the 31st power. Do the same thing on the other side. 4 times 5 plus 11 is 31, so you're good. 5 works. You have to check negative 4 though. So negative 4 squared plus 3 times negative 4 minus 9, that's negative 5. 4 times negative 4 plus 11 is also negative 5, so it goes work. You understand what I'm doing there? Is you're going to have to do it. Yes? We good? All right. Set 2 is different because they no longer have the same base, but you can find the same base. So here's what I usually do. Which one's the smaller of the two numbers, 9 or 8 and 1? 9. So think of it this way. Can I get 9 to the power of 81? Or sorry, can I get 9 to some power of 81? What? 9 squared. So I could rewrite this as 9 to the 4y minus 26 equals 9 squared. Agree? You take 1 9 squared. Now do they have the same base? Yeah. So what do? Set your exponents equal to each other. Add 26. Divide by 4. Y equals 7. Make sure the more you get used to plugging them in, the easier it will be to make sure that you know what you're doing. Number 2. 1 over 64 equals 4a squared minus 4. Okay. Which base do you want to deal with? The fraction or the non-fraction? Non-fraction, that's 4, right? Can I get 4 to the 64th power somehow? So we go 4, 16, 64, right? I know 4 cubed. I don't know how you have the patience to do it. I don't. I just walked away before I got fired. So, I know 4 to the third is 64, right? Now let's go back to what remember we talked about last week. If I want a fraction, my exponent has to be negative. So 1 over 64 is the same as 4 to the negative third equals 4 to the a squared minus 4. We cool with me there? Same base, yes or no? Yep, same base. So I'm going to have negative 3 equals a squared minus 4. What? Wait, so the yes, that's okay. It's okay. So I'm going to add the 1 over, right? I'm going to add 4. So a is what? Plus or minus 1. Now, you need to check to make sure this works. If I do 1 squared minus 3, it's negative 3. Negative 1 squared minus 4 is still negative 3. Yes? I would like you guys to try number 3, please. You have that? Yeah. Okay. What? Okay. Now, I know 32 is the same as 2 to the 5th. Agree? But I also know it says 32 to the m plus 3. That means this is also 2 to the 5th to the m plus 3 power. Power to a power, you multiply your exponents. So this is now m minus 9 equals 5m plus 15. Well, the only thing is, you got this to the 5th, yeah? You got that. So all I did is replace 32 with 2 to the 5th right here. Because the m plus 3 stayed the same. A power by exponent rules, a power to a power, you multiply those two exponents together. Which is how I got 5m plus 15. Because the 2 was already on this side, you don't need it. It was the 32 that became 2 to the 5th. Does that make sense? So this is 4m equals 24, so 6 equals m. Yes? Can you do number 4? Why not? Like, let's talk. What's the smallest base that you can talk about here? No. 2, right? 2. You don't want to do fractions as a base because you're not going to be able to get it. 2 is your smallest base. Can I get 2 to some power to get 12? I'm going to 2, 4, 8, 16. Can I get there? No. So do I have the same bases on this one? No. So can this one be solved? No, there's no solution on that one. Flip your paper over, please. Okay? Let's look at 5. I want to do like 2 or 3 more, and then I'll let you guys start your homework. Deal? Okay, let's look at 5. Let's look at 5. Okay. What are your 2 bases that you can see right now? 343 and 49. Now, if you take 49 and square it, is it going to be bigger than 343? Yeah, so that one's not going to work. We have to think of a smaller base. Yeah, 7. Okay, now let's talk. How do I get 49 with 7? 7 squared, right? But I need 1 over 49, so that's 7 to the negative second. So this would be 7 to the negative second, still raised to the edge of 4. Now, how do I get 343 with 7? 7, 49, take a wild guess. 343. Okay, so this is 7 to the third to the 2n minus 4. Now, both sides have a power to a power, yes? So this is 7 to the 6n minus 12 equals 7 to the what? Negative 2n minus 8. Does that make sense what I just did? Same base? Same base? So then I need to do what the exponents? Set them equal to each other. So 6n minus 12 equals negative 2n minus 8. Add the 2n, so this is 8n. Add the 12, so this is 4. So n is 1 half. N is 1 half. Try 6. Another one. Are we good with that one? Try 8. Try 8. Got 6, so let's do 8. Oh, that's not. That's going to be a 4. That's going to be a 4. Look at my my math wrong here? No, and that's my own equation.